How sure are you that you can get this question right? The atomic radii of a metal are usually that: A, equal to ionic radii; B, less than their ionic radii; C, less than those of the non-metal in the same period; and D, greater than their ionic radii. The first thing you have to understand here is the meaning of atomic radii. What do we understand by atomic radii? This is simply the distance of the outermost electron to the nucleus. Now, this is what I'm saying. You don't have to get it wrong. Now, let's say this is a nucleus. Let's just assume that we have electron here. You can see the way I'm filling the electron. You fill singly before pairing takes place. Okay, so let's now say, and then this. So this is simply like a sodium metal. Now, the distance from this nucleus, this is our nucleus. The distance from the nucleus to the outermost electron, that's what we refer to as atomic radius. And most of the time, if you say atomic radius, they used to write it / ionic radius. But they are different, even though they are still the same. How are they different? This is a typical question that differentiates atomic radii from ionic radii. What you have to know is that atomic radii is simply talking about atom, while ionic radii is simply talking about ions. It's not aeon, it is ions. Now, when they now ask you that atomic radii, that means whatever you have to use in maybe your question or your answer must be an atom. But if it is ionic radii, whatever you have to work on must be an ion. Okay, now they said atomic radii of a metal are usually dash. Now they want us to compare atomic radii and ionic radii based on the options that is here. Okay, we are talking about metal. Is metal usually positive or negative? I mean, is it cation or anion? So that means a metal is a cation. Everybody knows that. Okay, let's assume that we are using sodium. So we have a sodium atom and we have a sodium ion. What is the atomic number of sodium atom? Sodium atom is always 11, right? That's the atomic number. And when a metal loses electron, we give it a positive charge, right? That means sodium ion is going to be 10 electrons. So let me just put electrons. Do you understand now? Okay, now let's draw a shell representation for this. This is the shell representation for sodium atom and sodium ion. This is 11 in total, 11 electrons, and this is 10 electrons. Now let's determine the atomic radius. Remember, I said the distance from the nucleus to the outermost electron, right? So this is our outermost electron, and these are our outermost electron also. So let's say the distance from here to here, right? And the distance from every of these, because they are all in the outermost electrons. So let's say distance from here to here. Now, between this line and this line, which one is larger? I mean, which one is longer? You can simply say that sodium atom is having longer atomic radii because the radius is too large. The distance, let's assume this is 5 centimeters. I'm just assuming. This can easily be like 2 or 3 centimeters. Do you get that now? So atomic radii for metal, mostly you know that metal will lose electron, and that's going to reduce the number of electrons on their shell. That makes the atomic radius of metal in the ionic form to be reduced. Do you get that now? So let's go back. From here we can see that sodium atom, which is metal, has larger atomic radius. This is atomic radius, or you call it radii, and this is ionic radii. So it has higher atomic radii to ionic radii. Now, which one correlates? Equal to ionic radii, obviously it's not equal because sodium ion will have lost 1 electron. Atomic radii is greater, so which is option D. Atomic radii is greater than the ionic radii. If you have any question, let me know in the comment section. See you guys in the next video.